Do my best. Okay, so right, so a stack. First in, last out, or last in, first out. Usually it's last in, first out. Okay, Pringles. Stack. What else?
What else is a stack?
Give me another example of a stack.
Deck of cards.
A deck of cards. You don't deal from the bottom of the deck. If you're stacking the cards, now I don't know that I'd really, I mean, like, you don't really stack the cards like one by one and then take the first off.
Pancake.
Do you eat your pancakes the top one, or do you like slice through the whole stack?
Top one.
You do?
I take the top one off and then I pop it off.
Okay. All right. Yeah. But it's definitely a stack. What else?
Like in the computer when you copy something in the, what is it called, buffer?
The copy buffer. The last thing in the copy buffer is the first out. Although I don't know that I'd call that a stack, because I think the buffer just gets replaced every time. You lose your history. But there is another really good computer example of a stack. Call stack and browser history, both of those. Browser history is a great stack, right? When you go back, you don't go back to the first thing that entered in your browser history. You go back to the last thing that entered in your browser history. And the call stack. What is the call stack, Sabrina?
It's part of the JavaScript create engine. It's where our functions go to get popped off the call stack when they're executed.
And what makes a new function pushed onto the call stack?
What makes a new function?
Yeah, how does a function get pushed onto the call stack?
It depends if it's an asynchronous or synchronous function, I believe. I know, like, async functions, I believe, get pushed into a, this is a lot.
Okay, yeah, that's okay.
Another execution context and add it to the queue. And once the call stack is clear, this thing keeps checking to see if it, I don't know the word of the thing right now, but
event loop, yeah.
Event loop keeps checking to see if the stack is clear. That means nothing's on it. Once it's empty, then the asynchronous function gets pushed onto the call stack and executed.
Yeah. Okay, good. So the call stack in general, the call stack is, if you open a function, it gets pushed onto the call stack. That open function is on the call stack. And then once that function finishes, it gets popped off the call stack. You open another function, it gets pushed onto the call stack. How does a call stack get multiple functions?
Doesn't it do it, what do you call that? During the runtime? Or not runtime, but yeah, during runtime. Could add it to the call stack during a
yeah, but how do you get multiple? And it's when functions are nested. So if I have, actually, I don't think I want to do it there. I'll do it here. So if I have const a equals okay, and the first thing that happens, and then I have to call B down here. So when I call B gets pushed onto the call stack. And then B is like, okay, the first thing I'm going to do is call A. But B hasn't closed yet. B's not done. So A gets pushed onto the call stack too. So both B and A are on the call stack. So then A runs and it console logs hello. And then A finishes and it gets popped off the call stack. And then B console logs world and finishes, and then it's popped off the call stack. And the call stack is empty.
If you go into the browser and use the debugger, you can actually see the call stack getting populated with like nested function. And then as this code runs back, you see them sort of getting popped off
Nice.
in the debugger.
Cool. We're going to use, there's something called Python Tutor. When we talk about recursion, we're going to use it, even though, I mean, it's called Python Tutor because Python is the best of all possible languages, but you can use it for other languages too. Not tutorial. And it helps you visualize, and you can use other languages now, and it does all sorts of fun call stack stuff. When we do recursion, we'll work with this. But yeah, check it out if you're interested. It's called pythontutor.com. But again, you can use other languages with it. Okay, call stack. Okay, good. One of my favorite, we asked HackBright students for examples of stacks, and one of my favorite examples that somebody gave was teacher tenure and layoffs, right? The last teacher in is the first teacher to get laid off.
First one hired, last fired or something?
Last in, first out. Last teacher in,
Last
first
hired.
teacher out. Yeah,
Makes sense.
it's a stack. Okay. What about a queue?
First one in, first one out.
First in, first out.
Line at the bank.
A line at the bank. Easy. A line on a roller coaster.
B&B.
Okay, anything that's not physically people waiting in a line.
An order at a restaurant, like the way the orders come in.
Yeah, that's great. So the kitchen receives an order for a hamburger, and then they receive another order for soup, and then they receive another order. I was really irritated yesterday. I was waiting at the cook and her farmer, and I just ordered a large soup to go, and they made 5 other people's meals, full meals, before they scooped soup into a container and gave it to me because I was in a queue. Yeah. Yeah. So queues. First in, first out, or FIFO, FIFO. Stacks, last in, first out, LIFO, LIFO.
That's really confusing.
Really confusing.
LIFO, FIFO.
These
Lifo,
terms, they also use in what is it? Warehouse management.
Warehouse management. Okay,
Yeah.
tell me more.
Well, yeah, they some items in the warehouse, you need to let them use that principle, either this or that.
It's
Yeah,
either
so-
last in, first out, or first in, first out.
Yeah.
Got it.
So I noticed something interesting in terms of examples,
Mhm.
because I always thought of it as a line of people physically, but what I realized in the implementation is that with a line of people, if Stephanie moves out of the front of the line, I'm gonna move up and everyone moves up. But then you've got O of N instead of O of 1.
Runtime.
So what I realized is that a better example is like you were saying at the DMV, because you get a number and your number never changes, but it always goes in order.
Interesting.
So like
Okay.
the numbers at a grocery store, and you're waiting for the meat counter or something.
Nice. Okay, cool. Yes, we need to talk about runtime. Before we talk about runtime, I want to talk about what methods do each of these data structures need?
Oh, like a pop and push?
Yeah, so let's okay. So we have I hope this is was this Benitez?
He's gonna start over again today.
Let's not give him any advantages with the okay. So so we have a stack, and stacks sort of by definition have standard methods. Oh, no.
There's a blue one right here by your computer.
Thank you. This one needs to be de-sixed. Okay. That's perfect. Okay, so so what do you need to be able to do with a stack? Pop and push. What's pop? You take the first one off or the top,
Which was the last one in.
right, the top item off and return it. That's important. Push is what?
You add or insert.
And at the
We-
beginning.
We add a new item to the top or the bottom? To the top. Right? Anything else?
Shift and unshift.
Not part of a stack.
Oh no?
No, a stack, and this is really important. A stack, you do not care about anything but that top item. You just don't give a shit about what's going on down here. If you did, you wouldn't be using a stack.
You can peek.
Peek, what's peek?
You just see what's there.
Look at the top item, but don't remove it. Okay.
There's empty.
Um,
Do you want more?
by the way, like somebody should take a picture of that and just like do a poll for people who haven't seen it for like what word that could possibly be. What's the last one?
Well, there's empty. There's a couple more. You can check to see if it's empty.
These are the classic four. Is empty. What should that return? What data type?
Number.
Boolean?
A Boolean.
Oh, really? It only just does true or false?
True or false? Remember, it's a stack. We do
Size.
not care about this shit, right?
Size.
Size does. That's not really a classic stack. I mean, these four are like the classic stack methods. If you were implementing a stack, you would want to make these four methods. Yeah, Alex.
Why is it important to return when you pop?
Because the use case for pop, when you're going to use pop, is probably because you want to do something with the top item of the stack, right? So you want to both remove it from the stack and have it accessible to you to do something with.
Like if you're using, like I'm making a calculator. I remember.
Yeah, making a calculator. Yeah, doing a prefix calculator is a really good stack operation. Okay, so is empty. You return a Boolean whether stack is empty. Okay. Notice things that you cannot do with the stack. You cannot see what the fourth item is. Not one of the classic methods. You cannot see what the first item in was. Who cares? It's a stack. Okay. So your implementation, how are you going to store this data? Classically, stacks can easily be stored in an array. So if we have an array, and instead of top, we can think of the end of the array. And JavaScript arrays are not arrays, they're actually hash maps, so screw you, JavaScript. But, okay, I'm going to talk about classic arrays and not JavaScript arrays. Classic arrays are continuous spaces in memory. And so you can go to one particular space in memory by knowing where the array starts and how much memory is allocated for each block. And that's why arrays are O of 1, constant runtime to index, to go to any particular space. Okay, so fine. So we have an array. What is the runtime of removing the last item of an array?
Oh,
O of 1. Really? In an array, it is constant runtime to get to the last item, and it is constant runtime to deallocate the memory. And you also, arrays store the size, but it's constant runtime to decrement the size by 1. Constant runtime. So pop, if we use an array to implement, Pop, O of 1. Push, what's the runtime to add a new item to the end of an array?
Depends.
One.
I mean, if push was implemented in a way that like it knew the last number of the array, then it could do a
It
O of
always
1.
does. Classic arrays, it stores the size as part of it stores the size and the first location in memory.
So I mean, it could do a O of 1 lookup of size minus 1 and then push something into that position.
Adding to the end of an array is O of 1, constant runtime. Peeking, what's the runtime of that?
O of 1.
O of 1. Getting to the last item in an array, constant runtime. Is empty.
O of 1.
Why?
You're just looking to see if there's anything in there.
You can look at the size, if the size is 0 or not, constant runtime. None of these depend, so if we use an array to implement, none of them depend on the size of the stack. Let's do a queue. We might not get to the exercises, but we can have discussion of that over Slack.
Is the runtime for classic arrays the same as for JavaScript arrays?
JavaScript arrays are hash maps. Would all of those be O of 1 for a hash map in JavaScript? Yes, I believe so. Whereas like Python lists are classic arrays. So use Python. Okay. A queue. What are the methods?
In queue, DQ.
Usually we say NQ, unless you're in France. NQ, DQ,
Peak
peak,
is empty.
and is empty. NQ is to push to the end. DQ, pull from the beginning or pop from beginning. Pop from beginning and return. Peek and is empty are the same as for stacks, except peek, of course, is show first beginning item. How's our runtime? We'll talk about objects in a minute. I want to do a classic array. How's our runtime with a classic array? What's our runtime to push to the end of a classic array?
Probably O of 1.
Constant. It tells us where an array stores where the end is, and that's all we need. DQ. What's the runtime to pop from the beginning of an array?
O of 1.
Maybe not.
It is not.
It said in there it was.
Not if you are using a classic array. If you are using a classic array, this is,
No, 0.
You actually have to take every single one of these and move them to a different location in memory.
Oh,
Mm.
so it's O of N?
If you are using a classic array, it is O of N. It's like if you had a piece of paper and you wrote out a list, and the first item always had to be on the first line of the piece of paper. If you wanted to remove that first item, you would have to erase every single one of them and write them on a different line. If you're using a classic array, O of N.
So unshift literally removes the first value out of that index and pushes all the other values up.
Not in JavaScript, because JavaScript doesn't use classic arrays, it uses objects.
Okay.
So
But actually, to be honest, actually in JavaScript it's going to be the same thing, because in JavaScript you have 1 pointing to this, 2 pointing to this, 3 pointing to this, 0 because computers, and so if you want to remove that first item, you have to change every single one of these, right? Still O of n. It's going to take a lot longer if you have a million item array. Arrays are a sucky way to do queues. We'll talk about a better one in a minute. Or they're a great way to do stacks. Sucky way to do queues. Peak. If we were to do an array, what's our peak?
So here peak returns the first one. Probably constant.
Is empty. It
Constant.
stores the length. That's one also. We're going to talk tomorrow about linked lists. A linked list where you track both the head and the tail will get us constant runtime for all of these.
So what's the good way to implement queue in JavaScript?
A good way to implement a queue in JavaScript is to use a linked list.
So we're doing that tomorrow?
No,
Okay.
when I say tomorrow, I mean next Thursday. Yeah. Stacks and queues. Okay, we have 5 minutes. Let's do one of the exercises. Which one should we do?
7.
7?
Yeah, reversing your input using stack.
Okay, great. What? Oh. Something
We're
is.
supposed to write a data structure to take in an input and to reverse it, and then using stack, like creating a stack using it to reverse it and then pushing it somewhere. And I got the string in, but I can't get it reversed. I can't pop.
Can't get it to pop. Okay, why? Come here. Okay, so let's go to the exercises, and you're okay. Screw you. Do this.
So Bonnie, every
Yeah.
time we're writing something like this, we have to, like, from my understanding, just to ask while we're getting this warmed up.
Mhm.
So we have to create like a function that is our stack, like we're creating that constructor function. Then we also have to create what push will do and what pop will do.
Yeah, if you are creating a stack from scratch, but I can do it without a stack. I can do it just with an array.
Of course you can, but that's not what you told us to do. You said to make a stack. That was the whole part of the problem. Was like, why are we even making a stack? Because we can just reverse it. We know how to do that easily.
Right? It says use a stack.
Yeah.
You don't have to make the stack. So
Yeah.
so we can all right, so I seem to have a JavaScript stack implementation right here.
It's like a cooking
Yeah, we read it.
I know, exactly. Yes, I'm sure you did read it. But let's actually take this and all right, so analysis, pseudocode. Jesus, this thing is huge. Just go away. Like, can't I don't want to have like less than half my screen be the actual stuff. But okay, so here's my stack. Great. Okay, so let's go into Okay, so now I have this stack. Oh, no. All right, so now I have, oh my God, you're killing me. Oh. Let's try again. Okay. Great. So now we have this stack. Here it is. It's a stack. I am going to do module.exports equals stack. Cool. So now I can import that wherever I want. So now let's do stack exercises. And we'll say numbers, we'll give a, oh, I should call it .js. Okay, and then I want to import, no, I can't do that here. Require const stack equals require.
This is all.
Okay. Why is it capitalized, by the way? Why am I bothering to do that?
Because it's a constructor.
Yeah, it's a class. Okay. Don't save. Okay, so now, why was I flipping back there? I'm not sure. Oh, I wanted to give a link. Okay, so number 7. Okay, so now, all right, so I have a stack. So let's just do a function. I'll say const reverse characters equals, what is it going to take in? Okay. You all do this all the time, right? Okay, so space delimited characters. Okay, what's it going to return?
Another string.
I'd say it's probably going to return nothing. It just said to print them out. So.
What?
Just says to print them.
Doesn't that mean it's returning?
Nope, print and return are totally different.
Print is just cataloging.
Exactly.
Missed that.
What's our plan? Yeah, Patrick?
I mean, you already have a stack, which is already going to put things in reverse order.
Mm-hmm.
So you just have to read, like you just have to console log from the length of the array backwards.
Okay. If we're going to use the stack, I think what I want to do is I want to push characters on the stack from the beginning of the string, right? And then pop characters from stack, printing as we go.
Mm-hmm.
Does that make sense?
Yes.
Okay. So first, let's make an array, or first let's make an array out of the characters. So const char array equals yeah, good. Is it? God, in Python
It's characters dot split and then invoked with just the quotes. Yeah.
got it. Okay, cool. Now we're going to push characters from the stack onto the beginning of, or push characters on the stack from the beginning of the string. So
Mm-hmm.
right,
Mm-hmm.
instantiating my stack. Let's see, we're going to say char array for each. And I'm just going to go through and I'm going to say char stack dot push the character.
Yeah.
Then here I'll say for because I want to just do this, or actually if we're going to do this really stack wise, there is no is empty. What kind of stack is this? It's just empty. It actually doesn't have an is empty. It just is like, okay, so we need to write our own is empty, motherfuckers. Okay, so
Oh, it has a size.
I don't, that's not classic stack. Okay. Who chose this? Okay, so let's rewrite this. Returns Boolean whether indicating whether stack is empty. Okay. So we actually, so screw this. If this dot is empty, and then screw this, and now we can say stack dot prototype dot is empty. Return this is a Boolean expression.
Mm-hmm.
If it's 0, I want to return true.
Yep.
If not, I want to return false.
Yep.
Fair?
I have a question, Bonnie.
Yeah.
That prototype, you're just adding this method to the class?
You are adding this method, you're making this method available to any instance of the class.
Okay.
Okay, so while the stack is not empty,
So if you had a deck card, push would just be like stacking them and then pop drawing off the card.
exactly right.
The Q would be taken from the bottom of the deck of cards.
Which means you're never invited to my poker game. Yeah.
So we pop and what do we do is that?
We're console logging it.
So this is
So this line both takes care of console logging the top item in the stack and removing it from the stack.
Can we see it?
Let's see. So what do we call it? We called it reverse cars.
This is a thing. Okay.
Well, I'm doing a space delimited characters, but I can just say string. If you want, I can just do string of characters. So it says stack exercises.
Oh.
Exactly what I intended to happen. Infinite loop of undefined.
Good job.
Thank you. You may all go to lunch now. Okay, so let's figure out what's going on here. Oh, it's because I split it. Although,
You didn't have to
That
change the
still would
form.
have like split it on the 4 different words though, right?
Mhm.
yeah, it would have. So what the fuck? Okay,
Did
I
you
so
not
think
join it?
when you define the prototype is empty, you
Yeah.
can invoke it on the pop. In the if statement, like if stack dot is empty. equals null.
oh,
don't know if that's the cause of
I actually think I did. I changed it. I changed it to is empty.
But don't you have to like invoke this dot is empty?
Yeah. Thank you, Patrick. So
I know.
wise. Let's try again.
Hey.
Patrick for the win.
Cool. Now we can go to lunch.
Now we can go to lunch.
Oh, I can start. Oh my
Data structures are super fun. I'm not going to make a GitHub repo with this. I want you to do it yourself.
Okay.
But if somebody does it themselves and wants to share a GitHub repo, that's
You've been
fine.
recording this, right?
I have.
Okay, good.
Although honestly, I don't know that my voice has been recorded,
Oh,
but
that's what I wanted, your voice.
okay.
No, I just want your voice because I can understand.
Yeah, okay. Well, we'll see what
See you
happens.
in and you did something else. And then it's